Remember that when solving a system of equations with three variables by hand, you want to get two equations that have the same two variables. So we want to eliminate the same variable from two separate equations. I'm going to get rid of the z's because they're going to be the easiest to get rid of. The x's would also be a good choice, but we're going to start with these first two equations. And so if we add those two together, just as they are, we're going to get 6x plus y equals 9, and the z's will have canceled out. So now we need a different set of equations. And if we choose to use the bottom two, we're going to need to multiply this middle equation by a negative 3 so that we can have a positive 3z and a negative 3z. So I'm going to get negative 3x minus 6y plus 3z equals negative 15. Do not forget to do that negative 3 on the other side. And then let's rewrite the bottom equation and then add the two together. The z's cancel out again, and we're left with x minus 3y is equal to negative 10. We now have two equations with only x's and y's in them. We can solve this by elimination. So 6x plus y equals 9, and x minus 3y equals negative 10. You can feel free to use Cramer's rule here because it will get you the answer for both x and y without having to plug one back in to get the other. I'm going to get rid of the y's again because one is already negative and one is positive. So I'm going to multiply this top equation by 3. And we'll get 18x plus 3y equals 27. And on the bottom, x minus 3y equals negative 10. This is going to yield some unpleasant results. We get 19x equals 17. Something has gone wrong here. This is a good thing that this happened. You may have caught my mistake earlier, and I hope you did. If you get something tragic like this, if I'm asking you to do this by hand and is a 3 by 3, it means that there is a mistake. This would make much more sense if it were 17x. So let's just double check that we didn't do anything wrong here, which we haven't. So maybe we need to check our two equations. This one is looking great, but if you go over here to this x minus 3y equals negative 10, you can see the huge mistake I made, which is negative 3x plus 2x is negative x minus 3y. So let's put that negative right back up here and put it right here where it belongs, and now we get an appropriate 17x. So x is going to equal 1. When you plug 1 back in, you get, let's try it in the bottom equation, or in the top, it'll be nicer. 6 plus y equals 9. It becomes evident that y is 3. Hooray! We've got 1 and 3. We can choose any equation from our original array to plug it into. I'm going to plug it into the top equation because it doesn't look too crazy. So we're going to do 5 times 1 is 5. Minus y, which is 3, plus z equals 4. So 2 plus what equals 4? Z equals 2. We write it as a coordinate triplet of 1, 3, 2. I would suggest putting into the ref function of your calculator before doing it so you can catch any mistakes that show up. Good luck, and I will see you in class.